Good morning, everybody. Good afternoon. My name is Tassos, and I'm with RF Elements. And today's webinar is Migration to Horns 101. It's a webinar that will take you through how to migrate from your current sector technology to our horn antenna technology on your network. So to start, we'll talk about some of the problems when migrating to horns, kind of where people are when they're thinking about doing it. So in a lot of cases, people are just not really sure where to start. This could be, because perhaps you've tested our product slightly and don't really know how it performs or how to interpret the results. Maybe you've never seen our product before either, right? A lot of people are also unclear of the migration path, right? So how do you go from where your technology stands today as far as antennas on your networks and how to transition to horns and kind of move your network from the current traditional sector standard to a horn antenna standard. Again, maybe your initial test results were fuzzy. Again, perhaps you had an unclear understanding of the kind of gain to beamwidth relationship. Maybe you're unsure of how the antenna patterns of a horn are greatly different than that of a traditional sector. So again, if you're not quite sure from your original tests and how to use horn antennas properly, you might be having questions or issues migrating to horn. So hopefully we'll answer a lot of that. And then again, maybe you're totally lost. Maybe you've never heard of RF elements before and you have no idea what a horn antenna is. So hopefully we'll go through a lot of that information today to help clear up some of those potential problems you may have in deciding if horn antennas are proper for your network today. So what we'll do is, we'll go through some basic practices here to help you efficiently migrate to this new technology. So we'll follow some best known customer practices, right? This is basically the feedback and the kind of know-how from the field, from users of horn antennas, right? So we'll go through some of the best known practices that customers have done to successfully migrate horn antennas into your infrastructure. To efficiently migrate to this new technology, it's important to really solve the problem you're actually having, right? So having a clear understanding of what your issue is, whether it's poor latency, whether it's poor throughput, whether it's high amounts of noise, really understanding what your problem is will help in deciding which of our horn antennas to use and how to use them properly. So solving that actual problem makes a much more efficient migration of horns into your network rather than just say, let's just throw horns out there. Also, understanding the spectral limits of your area. No WISP is the same, no deployment scenario is the same. And when it comes to spectrum, again, the spectral limits of your area are going to be very different from others. So understanding what frequencies are available, what frequencies are usable, what frequencies will be usable if you go to horns. These types of scenarios are important to understand when migrating and to make it a more efficient migration into your network from traditional sectors. And even though horn antennas are very spectrally efficient, they have very high noise isolation, they allow you to do a lot more than you thought you can do. You still have to use your spectrum wisely, right? So again, it's not about using horns, having all these available channels, and then just gobbling up as much bandwidth as possible, right? So using your spectrum wisely will help you migrate because it'll help you grow. So these are some of the things that, again, if we look at how your networks are set up and how things are running in your particular area, you'll have a much more successful migration path with horn antenna technologies over your traditional sectors. Part of the breakdown that we'll do is basically two basic methodologies. The first method is the augmented coverage, or this is the hybrid deployment. This is the scenarios where you actually have your traditional sectors or your current sector technology, and you use horn antennas in conjunction to augment the coverage patterns that you have to help fill in gaps and do other things. So this is one method that we'll go over and seems to be the most popular when migrating to horns. And then the second method is, again, the brand new build out, nothing but horns on your tower sites. These are the two. And then we'll go through the conclusion to kind of wrap up these two methodologies for migrating horns into your network and go over some of the pros and cons of that. So before we get into the in-depth, we're going to go through some of the kind of precursor stuff that's important. So, you know, a lot of people think that when you migrate to horns, you have to forklift your whole network, which means basically tearing down what you have and rebuilding with horns. And that's really not the case. With horn antennas, you don't need a full forklift. It's something that can be transitioned into and slowly migrate over. So if we look at kind of this deployment here on the left, we can see your standard, you know, 4-sector deployment. You don't need to tear it all down. You can actually fire up your horn antennas, slowly migrate your customers off of your traditional sectors onto your horns, and then decommission your old traditional sector. So the upgrade path is actually quite smooth, and in most cases, you see practically zero downtime on the customer side. So this is something that's a perception that some people have when you go to horns. That's not really the case. So a full-out network forklift is not needed. A slow transition is more than possible when you transition to horns on your network. Knowing where your customers are, this is something that's really important also to know before you start your migration. Because traditional sectors are extremely sloppy, they have very large side lobes, very complex side lobes, back lobes. You really have zero control over the emission of radio frequency from your sector. Knowing where your customers are before you migrate are important, because what we find, or what a lot of WISPs find, is that their customers aren't connected to the front of the sector, right? So when your network is set up this way, it could be a problem in transitioning, because once you deploy your horn antenna, you will quickly find the customers that were not connected to the front or the particular sector that you thought they were connected to, and therefore will cause an issue because customers will drop off, right? Since we have no side lobes and very good front to back, you won't be as efficient when you're transitioning your customers to horns if you don't know where they are. So this is a really important first step in transitioning to horns. Using the right antenna for the job is also very important, right? So often sector antennas are extremely high gain and are usually overpowered for your coverage area, right? So, you know, picking the right horn antenna based on the distance that your customers are from the tower is very important as well, because this will help you be more spectrally efficient, because you can use a wider, lower gain horn antenna and not pick up as much noise as you were with your traditional sector. So again, knowing where your customers are will really help in choosing the right horn antenna for a particular azimuth on your tower or for the whole tower planning that you have. The same thing goes for, again, utilizing or dealing with customers in very diverse topologies, right? So often you may have multiple sector antennas using different down tilts to cover further out customers versus closer in customers. And this becomes a problem when you start overlapping very wide sector antenna coverages over each other. You start creating really big problems, a lot of errors, retransmits, and really poor degraded performance. So again, knowing where your customers are and how they're deployed or spread out within a particular, again, azimuth of a sector will help you choose the right antenna. For, in this example, you may have in the center azimuth of a particular coverage area customers at a further distance. So with horn antennas, you have the ability to deploy multiple horns with different down tilt on each, with none of the beams overlapping, to really create the coverage pattern that you need with zero overlap. So again, this is very important to use the right antenna for your deployment and understanding which horns you're going to use before you go ahead and actually deploy them. The same thing happens with high density deployments. So this is, kind of situation where you may have multiple sectors covering the same exact area because you just need more AP capacity, right? And this is really this is the worst case scenario for you, where you have two sectors set at the same kind of down tilt for the same coverage area, where with horn antennas, again, you can either use a lower gain, wider one, let's say if they're really close in, or if you need to use higher gain for more distance, you can use more narrow horn antennas to cover the same area, and again, not use as much down tilt on each to get you the AP capacity you need without having the beams overlay each other, which again causes huge issues with today's Wi-Fi chipset. So understanding this before you deploy is really important as well. And then a balanced network is a very happy network. If we look at kind of the coverage area of a traditional sector, it's usually broken down into a couple of different areas. Usually the center azimuth is kind of the sweet spot of a traditional sector. So this is where you'll find the majority of your customers that are connected to a traditional sector, here highlighted in white pins, have the highest MCS rates, because this is where the kind of sector antenna performs at its best. Nowhere near as close to a horn, but still it's the best part of a traditional sector kind of coverage area. As you start moving towards the edge of those of that sector antenna coverage, the gray and kind of the darker black pins, this is where your sector, your beam performance really starts to degrade. I'm sure a lot of you have noticed that the customers that are at the edge of the sector, whether they're out at the furthest distance or out to the furthest side of a sector, this is where you start getting big chain mismatches, where chain 0 and chain 1 have these large deltas of 2, 3, 4, maybe even 5 dB difference. When you have these huge differences in chain-to-chain performance, this is where you get those lower MCS rates. And what this all comes down to is the AP as a single device now has a large diversity of MCS rates in order to communicate with. And this terribly reduces the throughput of your radio, because the CPU load goes through the roof, trying to constantly change modulation rates, where it's talking to the customers in the center, it's at a higher modulation rate, then it has to send packets to customers who are at the edge of the sector, and now it has to modulate the radio down to suit them, and it's going back and forth. So not only is there a CPU load impact, which brings your network throughput down, but every time the radio has to change a modulation rate, you're taking milliseconds from the radio to change where you could be delivering packets. So overall, this is just an absolute disaster for your radio, and the overall throughput goes down. If we look at how horn antenna beams look compared to traditional sectors, the vertical and horizontal polarities are identical. So you may have customers that have varying MCS rates as well, but the delta between MCS rates is actually much smaller. So therefore, the CPU is not spending as much time changing modulation rates. You're not losing airtime while it's changing modulation rates. So actually the overall throughput will be higher of that AP versus one on a traditional sector. So you may actually find slower speeds, potentially, right? Your CPEs or your customers might actually have slower connection rates as a possibility, but it'll be more stable. So that more stable connection will actually deliver more reliable throughput, which is a better overall experience for all your customers than having some customers with high mod rates and high throughput, and then a bunch of customers with much lower throughput. So a balanced network actually is better even at a slower rate than a unbalanced network where modulation rates and throughput is constantly changing. So a balanced network is a much happier network. And the final point is understanding the technology. So horn antennas, again, are drastically different than what you're used to in every aspect of RF, right? One of the biggest misunderstandings is how the beam or how signal drops as you incorporate down tilt, or how the signal drops off as you start going to the edge of a horn antenna pattern. So the tilt factor, the drop off of signal on a horn as you adjust up tilt or down tilt drops off at the same exact rate as it does at the edge. So if we look at here with a horn with 0 down tilt, you have exactly full gain right at the horizon. So as you start to tilt the antenna up or down, you start to bleed off gain. So with a horn that had, let's say, about 12 degrees of down tilt, you are effectively bleeding off the gain, and you can actually control the amount of signal received at the horizon. So again, tilting an antenna up and down, you see gain at the horizon decreases and increases as you go from and to from the 0 bore site. So again, understanding how the -3, -6 beam patterns of a horn work is very important when you're deploying your networks, and can actually work to benefit you rather than be what's misunderstood as the downfall of a horn. It's actually a great benefit if you understand how the gain drops off. So now we'll come into the different types of methods for transitioning horns, now that we have a kind of better understanding of how horn antennas work, how their beams are different. So in the augmented coverage, there's usually, you know, some different methodologies on why people choose augmented coverage, right? So a lot of times you're just trying to offload oversubscribed APs, right? So you clearly have an access point that's covering a specific area that has way more customers than that access point can handle, right? Or maybe you're just trying to add capacity to your towers, right? So the augmented coverage kind of methodologies can help you if this is the kind of problem that you're trying to solve, right? Maybe the majority of your customers are actually close into the tower, right? So using a kind of wider, lower gain horn may be a better scenario for you in augmenting your coverage. Maybe you're just trying to pull in a huge cluster of close-in clients to a horn while keeping the rest of the customers on your traditional sector. Perhaps using the larger, narrow horns for high density deployments, right? So again, this is another methodology of augmented coverage that we'll go through, and some scenario that might correspond to what you're trying to do. Maybe you're just trying to add higher throughput packages for specific types of customers. Again, this is another methodology of the augmented coverage with traditional sectors and horns on your networks that we'll go over. And then, you know, using horn antennas in between your sectors to improve the edge of sector performance. So kind of like we talked about earlier, where the customers that are at the edge of your traditional sector usually have much lower performance because of the kind of the imbalance of how the vertical and horizontal beam coverage of a traditional sector is. You could use horn antennas to offload those customers and keep kind of your current customers in the sweet spot or the very narrow center part of your traditional sector. So these are some of the scenarios we'll go over in a little bit more detail to help explain those. So in the offloading or adding capacity, it's quite simple. So, here we have, a 4-sector deployment, and we have 2 sectors highlighted in red where there's really poor throughput on those APs. Again, because you have, let's say, too many customers, you can't get beyond that 30 customers per AP, and you need to add capacity, right? So you want to offload. So using horn antennas can be very effective here, where maybe you put up some narrower 30 or 40 degree horns and offload those customers or some of those customers onto the horn enabled APs or your access points with our horn antennas on there, and therefore alleviating some of the stress or some of the overload that was on your original AP, therefore helping to improve the throughput of the customers that are left behind on your traditional sector, and of course getting great performance of those customers that you've offloaded onto the horn antennas or horn antennas. Using a smaller, wider horn for close-in customers. So perhaps you're covering a rural area, so you think you need a traditional sector to cover this kind of wide angle and long distance, but maybe the center of town, you have a high density of customers that are on this particular AP. So some of our lower gain, wider horns may help in this situation where you can fire up a second AP in that area and offload those customers again onto the horn, and therefore leaving kind of your further distance, lower MCS rate customers on the traditional sector. So this can again help kind of increase the overall throughput of that particular azimuth or coverage area from your towers. This is another potential use case for augmenting the coverage with horns and your traditional sectors. Using larger, narrower horns for high density. Again, maybe in your coverage area where you're using a traditional sector, maybe a new housing development came up or some condos or something where there's a much higher density or large cluster of customers somewhere in that coverage area. You can use horn antennas to kind of spot beam those customers. So really point that particular horn right at that cluster of customers, again, offload them onto the horn antenna AP, and then again leaving the rest of your customers on the traditional sector. So this is a very common practice that's used often when augmenting your coverage with traditional sectors and horn antennas. Potentially selling higher throughput packages with horns. Again, this is something that's very common. You may have an area of town where there are businesses, or maybe you just have some particular customers that happen to be close to each other that want higher throughput packages. So you can actually, again, use horn antennas in the same way to kind of spot beam those particular customers and offload them. Maybe these customers have SLAs with their service, right? It's not your standard residential best effort type device, right? So when you have multiple customers or a diversity of types of customers in the coverage area, it helps to offload those very specific speed packages or SLA enabled packages to horn antennas to again deliver a different quality of service for a particular group of customers. And then instead of leaving them all on your standard traditional sector AP. Improving the edge of sector performance. So here, if we're looking at kind of a tower that's overloaded, if we look at, again, kind of the signal quality disbursement of customers on their traditional sectors, you'll see a much poorer or average signal as you get to the edge of that sector. Maybe some of those customers are further out, whatever it may be, but there's a much lower MCS rate or data rate for those particular customers. You could use horns in between those sectors to again try and bring those customers in onto a less loaded, better performing horn antenna AP than actually keeping them all on your traditional sectors. This is actually extremely common, and it is because traditional sectors are such poor RF performers that people are finding a very high success rate in augmenting their coverage to, again, improve the areas, not necessarily at the edge, but wherever you may have poor performing customers in your traditional sector coverage area. Using horn antennas to help improve that is a very, very common practice. So the augmented coverage kind of methodology is actually, it's very common, but it's really not the end game, right? As long as you have traditional sectors on your tower and they don't go away, you're always going to have a problem. It's not until you go to nothing but horn antennas that you can actually see the absolute best performance, right? So you'll get this kind of sense of better performing because you have some horns, but those horns will do so much better if they don't have kind of the side lobe interaction of traditional sectors to deal with. So it's not until you replace all of your traditional sectors with nothing but horns that you'll see the absolute supreme best performance that you can get from your wireless network by removing those traditional sectors. That's really should be the end game, because again, you won't get the most spectral efficiency, you won't get the best use of all your channels as long as you keep traditional sectors on your towers or in your deployments. So if we go to kind of the new tower build out, right? So this is a much simpler approach, let's say, where you're not augmenting your coverage. So if we look at it, there's different types of 360-degree coverage with horns. A lot of people, they're still stuck on this uniform, 4 90-degree, 6 60-degree, or 12 30-degree horns. And really, we offer so many different horn antennas in different beam angles, from 30-degree up to 90-degree in 10-degree steps, that you can kind of build your coverage, and it doesn't have to be this kind of uniform coverage. So building custom coverage based on your actual customer layout with mixed horns is very, very unique to the RF Elements horn antenna brand, right? We're the only company that actually allows you to build these custom coverages based on distances, based on wider or more narrower azimuths, which it's not possible with traditional sectors. And then the third part, other than your kind of uniform and custom, is just adding horns as coverage is needed. So this is kind of the slow build out and kind of building density based on the necessity for density, right? So perhaps you're in a rural area where you don't have a large customer base yet. You don't have to kind of deck out that tower with 12 horns and have all this capacity. You can kind of build there. So we'll go through these different type of build out scenarios on towers with nothing but horn antennas. So in the uniform coverage, again, it's quite simple, right? So this is where you use 6 60-degree horns or potentially 12 30-degree horns based on distance, density, and number of customers, right? So this is the uniform coverage. It's quite simple. It's just your basic, geometrical shapes that most people build their towers based on. So there's many different types of uniform coverage. If we go to the custom coverage, this is a very unique thing. You may have areas around your tower where you have really high density, right? So that's where you could use more narrow horns in order to build, put 3 30-degree horns to cover 90 degrees versus just using, 1 90-degree horn. Maybe you have an area that's less dense, right, where you can get away with a 60, 70, 80, or even 90-degree horn. So this, again, allows you the ability to use not only the resolution of the width of the horn, but also, as we talked about understanding your technology, you could also use narrower horns and effectively give them less gain by utilizing down tilt to kind of, again, paint the coverage of your area, and this really helps become you become spectrally efficient, because with traditional sectors they have so much gain, and their beam patterns are so uncontrollable or so wide. Not only are you sending noise or sending signal into areas that you may want to service later, that you'll have to combat later, but you're also hearing noise by having too much gain. So again, using the custom coverage and a combination of various degree beam widths of horns is a really great method, and really starts to show what horn antenna technology can bring to you that you may not be seeing with your traditional sectors. And adding horns as coverage is needed. You know, one of the big misunderstandings of horns is that, you know, you have to have the highest gain to start, therefore you need the most narrow, therefore you have to have 12 horns. And that's not the case. You know, you can start off with your 490s, and as density builds or as distance increases, you can put the higher gain, more narrow horns. Or if you need the density, you can use, again, the more narrow horns with down tilt to not hear as far. And you can basically build out and add your horns and upgrade your tower as things go. So this is kind of the migrating from horns to horns, you know, kind of the same migration path that you can do with the traditional sector to horns, you can also do, and then later reuse some of those other horns to build out newer towers after the fact. So adding horns as coverage is needed is very important. It gives you the ability to come in and start offering, you know, great service from the get-go with horn antennas, keeping it close into the tower. As word of mouth grows and as density grows and as distance may become a factor, you can again migrate and use different horns to again fill in those gaps and build out your coverage as you need it as time goes on. So as we think about all those different methodologies and different ways of utilizing horns, you know, we can look at some of these, the conclusion of all these different methodologies. You know, using the correct size horn for your coverage area, again, is very important. You know, everybody always kind of wants to run to the highest gain. This is kind of an old way of thinking, and it's based on, again, your experience because of the antennas that have been available and used in this industry for such a long time. Really, it's not really necessary. So using the right size horn for your coverage area is really important. So take some time to understand that, you know, knowing where your customers are before you deploy. I mean, this should be the case no matter what you do, but when you're migrating from traditional sectors to horns, it's really important to understand and know where your customers are. And to just kind of give some background, I see this a lot personally, where, you know, a lot of WISPs sometimes have contractors who do the installs for them, right? And, you know, you kind of give your contractor this kind of go, no go gauge, right? The customer has to be between, you know, neg 50 and neg 60. If it's anything over neg 60, you shouldn't connect them, right? So they go out to a tower and they may be using a higher gain CPE, and the customer happens to be a mile away from your tower. It's extremely easy on traditional sectors because of their side lobes to connect to the back of a sector and get a neg 50, neg 55 at a mile away with like a power beam 25 or some sort of CPE with that kind of gain, right? So you really don't know, you know, that your customers are connected to the main beam, where with horn antennas, you know, you don't have that problem, right? So knowing where your customers are before you deploy is really important. It will make the migration to horns much easier. Using down tilt as needed to actually achieve your goal, right? So again, understanding the relationship of how gain drops off as you tilt the antenna down is really important. And we have a link calculator on our website to kind of help you figure that out as well. So using down tilt where it's needed, you know, don't intentionally use too much down tilt because you're trying to deafen it as much as possible at the horizon. Use the amount of down tilt that's needed to make your link budget. So understanding that is really important before you migrate to horn antennas. Build a balanced network with horns. Again, this all comes back to using the proper antenna based on distance, based on coverage area. If you build a balanced network, right, where the diversity of connected clients and their data rates are more uniform, you'll have a much better running network. You'll see latency drop dramatically. You'll see ping times improve dramatically. You'll be able to offer much better kind of packet sensitive services like voice and video, right? So you can't do that if your network is built out and unbalanced. It does nobody any good to have customers with extremely high data rates in one portion of your network and then really low data rates in the other, in another part of your coverage area. So building a balanced network should be really important when you start thinking about your migration path, and using the right antennas and these different methodologies will help you build a balanced network. The hybrid antenna solution is really not the best approach. Again, maybe it sounds too far-fetched or it doesn't sound true, but honestly, when you have nothing but horn antennas on your tower, you will really see what we say every day, right? Honestly, if your horn has to deal with the side lobes of traditional sectors or poor performing antennas on your tower, you'll still get good performance through those horns, but you'll never see what they can really do until you alleviate all of that. So the hybrid antenna solution is not the best approach for your end game. It's a good methodology to transition and migrate the horns, but the overall goal should be to, eliminate all traditional sectors from your towers. And again, if you go beyond that, it's even point-to-point antennas. Again, side lobes kill, and the hybrid antenna solution is not the best approach. And then finally, plan before you deploy, right? So again, think about what you're going to do, look at the deployment, what you're trying to achieve, and then use the right antenna for the job, and your migration path, or your migration effort will be much lower, and it'll be much smoother if you plan before you deploy. So a lot of you might have questions, and we'll get to those questions here at the end of the webinar. We have, there's a lot of resources available to you when it comes to our antenna technology. One of those great resources is our forum, right? rfelab.com. So you should join our community, join our forum, look around. You'll find a lot of interesting information there. Chances are you'll find a WISP that was maybe dealing with the same issue you're having right now, and you'll find the solution on how to solve it based on real-world customer interaction and real-world solutions from how a WISP like yourself has dealt with a problem. So our forum is a great place, rfelab.com. We have tons and tons of customer experiences and videos and product information on our YouTube channel. This is my favorite source for everything. We have interviews with specific WISPs and how they used our technology, how our horn antenna technology bettered their service, bettered their WISP, bettered their business. A lot of information. We have a series that we do which is called WISP Traveler, where we've actually visited WISPs and shown again how they incorporated our horn antenna technology into their networks and how it benefited it. And there's a large diversity from not only the US but from around the world, right? So chances are there is a WISP that's dealing with kind of your high noise environment, maybe your real rural environment, maybe again dealing with a situation where they're fighting the big telcos and trying to sell services. Whatever it is, there's probably a WISP out there that's dealing with the same type of issue you're dealing with, and it's a great resource to hear from them, because really you want to hear from a WISP how they're using our technology, not necessarily from us. And our YouTube channel is a great place to find a lot of that information and see how our antennas are changing WISPs every day. And finally, stay tuned. Again, we're all over social media. We're on YouTube, Facebook, Google+, LinkedIn, Twitter. I mean, we're everywhere. This is a great resource, again, to interface with us if you choose, and then really to interface with a WISP like yourself. Again, in the end, hearing from a WISP and how they're dealing with their problems is the most important thing. You know, our website is obviously packed with a lot of information, spec sheets. We offer tons of information, from antenna files to really detailed spec sheets on our antennas. So rfelements.com is a great place. Our forum, rfelab.com, again, another great resource. Any of these kind of, you know, well-known social media platforms. And again, you could always use email as well. You could always email me, Tassos, T-A-S-O-S, at rfelements.com or info@rfelements.com to reach out to anybody on the RF Elements team and help you with any of your problems. And then, like I said, stay tuned. We have a lot of great products coming. We're working really hard to really fix the 5 gig spectrum and make it great again. We've done a great job so far, and we have interesting stuff coming down the pipe. So at this point, we can go to questions and answers if people have them. If you haven't put one in the little text box or the chat box yet, please do. I'd love to answer any question right now that anybody may have.
Yes, thanks, Tassos. We are getting a few questions in. So the first one that I have here is, what is the difference between horn antennas as compared with smart antennas other than cost?
Oh, smart antennas, there's a huge difference, right? So smart antenna is not enough for me to truly answer. Based on that, I think maybe you're talking about the beamforming antennas or the smart antenna from Cambium. Again, a smart antenna is an array of antennas typically, right? It's a beamforming antenna where it has multiple antenna elements that are working together with a single radio, which is the important part, with a single radio to be able to direct the beam in a certain azimuth, right? So a horn antenna is totally different. It's a single radiating element on a single radio. So there really is no direct comparison other than single radio, single beam with a horn, and then the smart antenna is an array of multiple antenna patterns within one enclosure. I hope that answers it.
Okay, thank you. Another question is, how accurate is the RF planner height estimates and tree penetration?
Tree penetration. So we don't have a link planner on our site. We have a link calculator, right? So the link calculator is actually very accurate from feedback that we've received. It will allow you to pick your particular horn antenna that you want to know something about, input the TX power that the radio is going to have, and then pick the gain of the CPE you will use, and then again the distance that you want to cover. So you can drop the pins on the map and put where your AP is, where your CPE is going to be, and then start manipulating kind of the data rates of your radio and even the down tilt, right? So it's not going to tell you anything about you know, beam penetration through foliage or trees, but it'll tell you what signal you should get in a line of sight environment with any particular horn or antenna that we offer and your CPE. So the link calculator will again tell you what signal you should receive at the receiving end based on your real inputs of antenna, gain, noise floor, and all these other things.
Great. Are horns dependent on the AP for how many links it can put on, or are they limited to in their own way by design?
No, absolutely not. There's no limit to how many devices. The horn is just a passive antenna. It does nothing. It's all dependent on the radio itself, right? So whatever radio platform you decide to use, whether it's Microtech, Ubiquiti, Cambium, that's going to be the deciding factor. The only factor that the horn might play a part into it is how many customers are within that angle that are capable of connecting into the antenna, but there's no limitation factor. If you have 1,000 customers in a 30-degree beam, that horn antenna will accept all 1,000 as long as the radio can handle it, which nobody can, but.
Okay, and then I think this was also from the same person. So they're asking, is there any overlapping need to give best coverage with the horns?
There's no overlapping need. What we're finding again is that, you know, some overlap is perfectly fine. You know, people are too fixed on gain, right? And it's not about gain, it's about the coverage that you want. Some of the more successful WISPs are actually using wider horns versus the narrower ones, right? So if you look at our spec sheets show you the -3 to -6 beam width. And what, again, other people are doing are using kind of a 40-degree horn based on a -3 beam width of 30 degrees and giving some overlap. So this will help because the signal does drop off pretty sharp as you get to the edge of a horn antenna. So having some overlap can certainly help in coverage area and not having, let's say, dead spots. It's not an absolute necessity, but it could make your deployment a little bit easier. It's certainly possible.
Okay, thank you. Another question that just came in is, what makes horns better? Is it the waveguide?
Yeah, it's everything, right? So you know, and there's no just horn antenna, right? I mean, horn is a very, very generic term to describe what we've created, and what we've created is totally different. There's many types of horn form factors. Our horn antennas are made specifically, or the type of horn, the scalar horn, was picked and used specifically for its very clean signal. So we have the scalar horn will give you a very precise vertical and horizontal beam coverage, right? So again, the vertical and horizontal beam pattern that come out are practically identical, right? Where you don't have, you know, the vertical about 37 degrees wide and the horizontal is 26 degrees wide, right? So you get 30 by 30 vertical and horizontal. So this gives you that great chain-to-chain performance that we talk about within the coverage area. The other benefit that you get is extremely linear or flat gain across the spectrum. So very good frequency response. So the gain at 5.1 or the lower Uni 1 band is very flat across from 5.1 to 5.8 gigahertz. So it's this uniform gain across the spectrum. It's uniform gain in both the vertical and horizontal beam pattern, and it's the very uniform pattern of vertical and horizontal overlay. It's these things, amongst a few others, that give you the ultimate performance. If you dissect and you look at a traditional sector, it's the total opposite, right? So your vertical beam and your horizontal beam are usually, you know, or typically two different shapes or two different sizes. One's wider, one's narrower, or vice versa. So this gives you unbalanced beam performance from your coverage area. The gain changes dramatically again. You might have higher gain potential in the vertical polarity and lower gain in the horizontal. So this gives you again, ununiform gain, right, across the frequency spectrum and throughout the coverage area. So it's really extremely sloppy. So again, it's not just any horn, it's our horn that gives you the ultimate beam performance.
Great, thank you. So another question is, what is the best horn model you recommend for a really bad RF area?
So again, it really depends. This kind of goes back to using what's, you know, without knowing your deployment, it's hard to really say which is the best. I can talk in some general terms, right? So the more narrow the horn, the more noise isolation it has, because again, it's more narrow, it's looking at less azimuth. So, you know, as a kind of general statement, yeah, the 30-degree horn for, you know, symmetrical horn is probably your best bet in a high noise environment, because again, it's more narrow. So it doesn't necessarily mean that the 30 is better than the 40, right? You know, the 40 and 50 degree horn have better front to back than the 30 degree horn, right? So there's different aspects of what might make the horn better. But typically speaking, if you're looking at a more narrow eyepiece, you're going to see less noise. So the 30 degree horn, or our ultra horn, if you really want to go extremely narrow, our ultra horn is about 15 degrees wide as far as total beam width. So that would give you the ultimate noise isolation.
Okay, great. And we have one last question.
Mm-hmm.
What is the maximum recommended distance using Ubiquity's Gen 2 AP paired with a 30 degree cone?
Yeah, again, this is, you know, there's no spec distance. You have to use our link calculator. It depends on what the noise floor is, right? It depends on, you know, hopefully you stick to EIRP, but maybe you don't. It depends on what CPE, what's the gain of the CPE, right? So, I mean, I can give you some general numbers, but really that's the incorrect answer. The correct answer is looking at the link calculator and understanding specifically what hardware you're using. You know, distance also changes based on MCS rates, right? So do you want to know what the distance is at full 256 QAM, or are you happy at 64 QAM? Because if you're at 64 QAM, you can almost double your distance, right? So there really is no answer to that. Also, as you go to these higher modulation rates, you should really be bringing your coverage area in closer. It's really hard to maintain these high MCS rates at distance. Again, our link calculator will answer that for you in a second. If you just put in your CPE, the gain of your CPE, whether you're using a 30 dB rocket dish, is going to be a lot different from using a Power Beam 300 or 400. So.
Great, thank you. That's all the questions that we have, and that is actually all the time that we have. So thank you, Tassos, for the presentation and everyone that attended. Did you want to add any last words before we take off?
Yeah, again, I'm happy to work with anybody. So again, you can find me all over social media, you know, or you can email us directly. If anybody has any questions that they didn't ask or didn't want to ask, you can ask me direct. Just reach out. I'm here for you, and I look forward to hearing from each and every one of you. Thank you.
Perfect. Thank you. Bye, everybody.
Bye.